Hi guys, welcome back again to my channel, and for today we will go with summary chapter 3. We're down to 3. So let's start the chapter. Chapter 3, Network Protocols and Communication. This will be the objectives and the sections of chapter 3. Rules of communication, network protocols and standards, data transfer in the network. Rules of communication. The rules of communication. Communication fundamentals. All communication methods have three elements in common: source of sender, destination of receiver, channel or media, and rules of protocols. All methods of communication. Rules establishment. Protocols are necessary for effective communication and include protocols used in network communication also define message encoding, delivery options, formatting and encapsulation, timing, and size. Message encoding. Encoding between hosts must be in appropriate format for the medium. Message are first converted into bits by the sending host. Each bit is encoded into a pattern of sounds, light waves, or electrical impulses, depending on the network. The destination host receives the decodes the signals in order to interpret the message. Message formatting encapsulation. There is a grid format for letters and addressing letters which is required for proper delivery. Putting the letter into addressed envelope is called encapsulation. Each computer message is encapsulated in a specific format called a frame before it is sent over the network. A frame acts like an envelope providing destination address and source address. Message size. Humans break long messages into smaller parts. Long messages must also be broken into smaller pieces to travel across the network. Each piece is sent in a separate frame. Each frame has its own addressing information. A receiving host will reconstruct multiple frames into original message. Message timing, access method, flow control, response timeout. This will be the message delivery option. If unicast in unicast message, you just need to one delivery. In the multicast message, you set it to many one-to-many delivery. While on the broadcast message, you send it to one-to-all delivery. Network protocols and standards. Rules that govern communications. Protocol suites are implemented by hosts and networking devices in software, hardware, or both. The protocols are viewed in terms of layer, with each higher level service depending on the functionality defined by the protocols shown in the lower levels. Network protocols. Networking protocols define a common format and set of rules for exchanging messages between devices. Protocol interaction. Communication between a server and web client is an example of an interaction between several protocols. There are three protocols and one Ethernet: HTTP, TCP, and IP, and Ethernet. Protocol suits the industry standards. A protocol suite is a set of protocols that work together to provide comprehensive network communication services. The TCP or IP protocol suite is an open standard that the protocols are freely available and any vendor is able to implement these protocols on their hardware or in their software. Development of TCP or IP, Advanced Research Project Agency Network or ARPANET was the predecessor to today's Internet. This will be the TCP or IP protocol. So, when sending data from a web server to a client, the encapsulation procedure would be as follows. TCP or IP communication process. When receiving the data link frames from the web server, the client processes and removes each protocol header in the opposite order it was added. Open standards. Open standards encourage interoperability, competition, and innovations. Internet standards. Internet Society, Internet Architecture Board, Internet Engineering Task Force, Internet Research Task Force, Internet Corporation for Assigned Name and Numbers, and Internet Assigned Numbers Authority. Electronics Communication Standards Organization, Institute of Electrical and Electronics Engineer, Electronic Industry Alliance, Telecommunication Industry Association, International Telecommunication Union, Telecommunication Standardization Sector. The benefits of using a layered model. The benefits model include assisting in protocol design, fostering competition, preventing technology, and providing a common language. There are 7 OSI models: the physical, the data link, the network, the transport, the session, presentation, and application. The TCP or IP protocol model created it in early 1970s, an open standard, also called TCP or IP model, or the Internet model. OSI model and TCP or IP model comparison. The OSI model, the network access layer and the application layer of the TCP model are further divided to describe discrete functions that must occur at these layers. So this will be the OSI model and the TCP or IP model. Data transfer in the network. Message segmentation. Large streams of data are divided into smaller, more manageable pieces to send over the network. By sending smaller pieces, many different conversations can be interleaved on the network called multiplexing. Protocol data units. As application data is passed down the protocol stack, information is added at each level. This is known as the encapsulation process. Data, segment, packet, frame, and bits. Encapsulation example. The data is divided into segments. The TCP segment is encapsulated in the IP packet. The IP packet is encapsulated in the Ethernet frame. The encapsulation process works from bottom to top. The encapsulation is process used by receiving device to remove one or more of the protocol headers. The data encapsulated as it moves up the stack toward the end user application. Network address. The network layer source and destination addresses responsible for delivering the IP packet from the original source to the final destination. Source IP address and destination IP address. Data link addresses. The purpose of the data link address is to deliver the data link frame from one network interface to another network interface on the same network. Devices on the same network. The network layer addresses or IP addresses indicate the original source and the final destination. Network portion, host portion, source MAC address and destination MAC address. Devices on a remote network, sending to a remote network. Chapter 3.4 Summary. So, in Chapter 3, I discussed about the encapsulation and decapsulation, the message on how communication process do, and what we do on OSI and TCP or IP model. So that's all for chapter 3. I hope you understand something, and goodbye and see you next chapter.